In this problem, we consider 2D projectile motion. An archer tries to hit a target that sits 10 meters high on a castle wall that is 100 meters away. If the archer aims at 6 degrees above the horizon, what speed must the arrow leave to hit this target? Well, to begin this problem, let's draw a picture of the situation. So, let's draw the archer right here. Here's our archer. Right? Our archer is going to have a little bow and arrow. And let's give the archer an arrow. Okay, and that's the arrow right there. And this arrow is going to leave the horizon, which is the level ground, at an angle of roughly 60 degrees. Now, far away, there's a castle here. So let's draw a little castle here. Okay. Perhaps a low target. And there is the target. Okay. And this target is on the castle wall and is about 100 meters away from the archer. So that's at 100 meters, about the length of a football field roughly. Okay, and this target is 10 meters above the level ground. Okay. So this is 2D projectile motion, and so we must write down our 2D projectile motion equations. All right, let's begin. Okay. So there's two directions here. First is the x direction. Let's make this the positive x-axis pointing toward the castle wall, and let's make this the positive y-axis pointing outward. All right. So the projectile motion in any particular direction is just given by the final position is equal to the initial position plus the velocity in the x direction times time plus the acceleration in the x direction t squared over 2. Right? Let's write the same equation for the y direction. Okay? The final position in the y direction is equal to the initial position in the y direction plus the velocity in the y direction times the time plus the acceleration in the y direction t squared over 2. Okay? Now, as I drew in this picture here, the archer is on Earth, right? So the important thing to realize is that there will be a force of gravity that will be exerted upon this archer and upon any other system that, any other target that sits in the system. Okay, so let's basically put down our position. So our initial position, this is here, xi equals 0. Let's make level ground also y equals 0, so this will be y initial equals 0. Now the final position, right, is here, which is x final is 100 meters away, and the height of it is 10 meters up, so the final velocity, final position y is 10 meters. Okay. Now the arrow is leaving with some velocity. Let's say this velocity here is v, right? Okay, and it's going to leave with that velocity, which is something that we need to determine, right? Okay, so let's basically draw in this picture. So this velocity has two components: has a direction, has a magnitude, and a direction, right? The direction we know is 6 degrees above the horizon, right? And velocity can be divided in two components: the velocity along the y-axis, and then the velocity along the x-axis. Right? And because of the angle 60 degrees, we can write down that the velocity Vx is equal to V times, this is 60 degrees, so it's the cosine of 60, and Vy is equal to V times, in this case, the sine of 60. Okay, perfect. Okay, so right now we have all the information we need, except two more pieces of information. First of all, we ignore air resistance. We ignore air resistance. There's nothing resisting or accelerating the arrow in the x direction. So what that means is that no air resistance implies that ax is equal to 0. There's no acceleration along the x direction. But however, we're seeing on Earth, so there's gravity. So let's write gravity. This implies that ay is equal to, now which direction is gravity? Gravity is pointing downward. This is gravity. It's pointing along the negative y direction. So this is going to be minus g, which is equal to minus 9.8 meters per second squared. All right, perfect. So we have everything we need to solve this problem. So let's just get to it and just solve it. Okay. So let's write down these two equations now in a form that where we know new pieces of information. So for instance, let's start with x direction. So x final is equal to x initial plus vx t plus ax t squared over 2. I'm just rewriting these equations. Okay. Now what do we know? We know ax is 0, so this could be plus a 0. Okay. We know what vx is. This is going to be v cosine 60. We don't know the time, so we can write the time down. Okay. We know what x initial is. That's just 0 again. And we know what x final is. That's just 100 meters again. All right. So these two zeros just gives us 100 is equal to v cosine of 60 times t. Okay, beautiful. Let's write down the second equation. Okay, let's copy it down again. So y final is equal to y initial plus vyt plus ayt squared over 2. Okay, so let's put in all the piece information now. Okay, let's start with vyf, that's 10. That's equal to y initial, which is 0, plus vy is just going to be v sine 60 times t, which is something we don't know yet, plus ayt squared over 2. Well, what was ay? Ay is minus g, so this is actually going to be minus g t squared over 2, and minus g is just really just 9.8, so we could just eliminate this guy, 9.8 meters per second, if we want to keep it simple. All right, so we have these two. All right, let's just solve it now. Okay, so we have two things that we don't know about. We need to know v, all right, but we also don't know t. Okay, and here again the same combination appears. We know v, we want to know v, but we also don't know t. Okay, so the strategy here is solve for t here, plug into here, and then that allows us to solve for v. All right, so let's do that. Okay, so let's write down the two equations which are relevant. So that will be this one right here and this one right here. Okay, let's write down one more time. So it'll be let's make a little space for us. So say 100 is equal to v cosine of 60 times t. All right. Okay, and then the other equation is going to be 10 is equal to v sine of 60 times t minus 9.8 divided by 2 t squared. All right. Okay, so let's just solve it. Okay, so remember the strategy. We're going to solve for t here and then plug the t into this equation. All right. So this equation, we divide this out by v cosine 60 divided by v cosine 60. So that equation now gives me t is equal to 100 divided by v cosine of 60. Awesome. All right. Let's take this t and plug it into the second equation right here. So this is 10 is equal to v sine of 60 times t. What's t again? This is going to be 100 divided by v cosine of 60. Awesome. All right. Minus, now this equation right here, 9.8 over 2. What's t squared? Well, that's just this guy again. 100 divided by v cosine 60 squared. All right. Okay, so now we can proceed to basically solve this problem, right? To do so, we should note All right, so to do so, we need just to write this thing down. Okay, so let's just write down all the values that we know. 10 is equal to V. Okay, so this V will cancel out that V. So the sine of 60 is just 0.866, right? The cosine of 60 is 0.5, so it's going to be 100 divided by 0.5 minus 9.8 divided by 2. Okay, now this is going to be 100 squared is going to be 10,000 divided by V squared is V squared. Cosine 60 is 0.866. I'm sorry, is 0.5 squared, right? Okay, so now it's just plugging in numbers, right? Now if you work this thing out, right, this number here, if you subtract out 10 minus 0.866 times, this is going to be 100 over 0.5. This is equal to negative 163.2, which is equal to minus 9.8 over 2, 10,000 over V squared times 0.25, right? Now if you plug in the rest, what you end up getting is something like V squared. Okay, now just divide everything out. You're going to get something, isolate V squared. You're going to basically be able to show that V squared is roughly 1200. Let's write down the exact number. It's actually exactly 1201, which implies that V is approximately equal to 34.6 meters per second. All right, and that basically solves this problem. I hope this was helpful.